If you clicked on this video, you probably already know what a binary search tree is. If you don't, just read the description on the screen because I'm too lazy to add a voiceover explaining the definition. Anyways, how do we validate these bad boys? Well, it's quite simple, of course. We use recursion. And the way we do that is we perform a depth-first search where we pass in the root node, but also two more parameters. Negative infinity and infinity will be our left and right bounds. Every time we go to the left subtree, we update our right bound with the current value, and every time we go to the right subtree, we update our left bound with the current value. So let's get started. Is 5 within the bounds? Yes, it is. And because we now go to the left subtree, we update our rightmost bound with 5. Now, since 1 is less than 5, we know that it's within the bounds and it's a valid subtree. We now backtrack, and when we do that, we reset our bounds to what they were initially on that node. And now, since we're moving to the right subtree, we update our left bound with 5. We see that 7 is also within these new bounds, and then we move to the left and see that 6 is also within these new bounds. We then backtrack, update the left-hand side, and check that 8 is also within these bounds. So we have an overall valid binary search tree. Now, let's look at an incorrect example. We start from the root once more and go to the left subtree. At this point, you should probably know the drill. We update the right, check whether 1's within the bounds, backtrack, reset our bounds, and then go to the right subtree. Here, we seem to have run into a problem. 4 is definitely less than infinity, but it is not greater than 5. This means that this is not within bounds and we have an invalid BST. So that is how you validate a binary search tree. The space complexity is O of 1 and the time complexity is O of n. The recursion part of this problem can be tricky. You have to make sure in the recursive call that when you go left, you update the right bound with the root value, and when you go right, you update the left bound with the root value. Also, at each point, you have to check that if the current value is not within the bounds, you have to return false. Thank you everyone for watching. Once again, this has been a STEMViz production, and make sure you check out the other videos on the channel.